Well, looks like I made a mistake. I presumed that Ainsley would be able to understand and comprehend her own circuit diagram with the black function generator lead hooked up to where she always used it until the 11th of August 2013. But I was wrong about that. She's totally lost. So let's try something a little simpler. See if she can understand this. Alright, are you ready for this? Let's see here. Here's the main battery right here, okay? Red is positive, black is negative. I've got the negative connected to my earth ground, which is outside. It's a 4-foot copper pipe driven into moist soil. The yellow wire from the negative pole of this battery goes to the MOSFET gate, yeah, and nowhere else, right? And this red wire here connects to the positive pole of the bias battery, this 9-volt battery here. That's this red wire, okay? The minus pole of that battery will be connected to the MOSFET source, but right now there's nothing connected to the MOSFET source. See that? Okay. MOSFET drain is this red wire, goes to this 14-volt light bulb. This is a GE type 161 if you want to look it up. And then through the red wire to the positive pole of the battery. See that? So positive pole of the battery goes to the bulb and to the MOSFET, then through the bulb to the MOSFET drain only, right? And then I also have a voltmeter hooked up. This voltmeter is hooked up to the battery. You can see that I've got the black lead in the negative common and the red lead in the positive. The red wire goes to the red pole of the battery. The black wire goes to the black pole of the battery. So you know I haven't painted these different colors or anything. Alright. And on the 9-volt battery you can see that's the plus side and that's the minus side. Sometimes it's kind of hard to get the alligator clip to hang on to that plus side. Alright, there we go. Okay. Now I'm going to touch the negative side of this battery to the MOSFET source. What do you think is going to happen? Alright, the bulb comes on brilliantly, even right? So when I disconnect the bias battery from the source of the MOSFET, the bulb goes off, the battery recovers some voltage. Right? Now let's take the voltmeter and instead of hooking it across the battery, let's hook it across the MOSFET. Let's take this down here, the positive input to the voltmeter, and hook it to the MOSFET drain right there, very carefully. And the negative of the voltmeter still stays over here. It came undone, hooked to the battery, negative pole of the battery. Okay, so now we're looking at the voltage across the MOSFET drain. Alright, right? Drain to the positive input of the voltmeter. negative input of the voltmeter to the battery negative. It's hard to see against the black, but there it is. Alright. So once again, we start the circuit by hooking the bias battery to the source. Bulb comes on bright. MOSFET drain voltage goes way low. Right? Bulb is on. Drain voltage is way low, below the voltage of the negative pole of that battery. How can this be? Okay, so when I unhook the bias voltage to the negative bias voltage to the MOSFET source, the bulb goes off and the drain voltage goes high, back up to the battery voltage. Got that? MOSFET on, drain voltage goes way low. MOSFET off, drain voltage comes back up to battery voltage. That battery. Any questions? What do you think? All right, there it is. And here's that same light bulb, the very same one, just directly hooked up to the 9-volt battery. And I think you can see that it's quite a bit dimmer than it was before. And now I've put that bulb back in its socket, wired just like it was before. And now I'm going to use the 9-volt battery to supply the negative bias voltage to the drain pin. Okay? You see the difference in the brightness of that bulb? I think it comes through even through the video. Alright? Got it? Got it? Oh, and just in case you were wondering, no, the outside ground doesn't really make a difference. If I can unhook that outside ground. And just in case you think the power might have been coming in through the outside ground someplace, I've disconnected that. We don't really need it. Okay, so once again, everything's the same as before, except I've just disconnected that outside ground. And let's see what happens. And there it is. Bias connected to the source. There's the minus pole of that battery. Plus pole of the battery goes to the minus pole of the run battery, which is connected to the MOSFET gate. And still, when the light bulb and the MOSFET are on, the battery or the drain voltage of the MOSFET goes way low. When I turn the MOSFET off, the drain voltage comes back up to the main battery voltage. All right. Got that?